the distributive property hinges on the principle of the following idea. So let's say it costs 33 cents per minute to make a long distance call. So we're talking out of the country. And on 3 separate calls, we'll call them call 1, call 2, call 3, I talk for the following number of minutes. So 5, 10, and 20 minutes. I'm going to change this price so it's a nice pretty number. So we'll say it's 10 cents a minute. Okay, well that means that if you look at it on a call by call basis, on the first call I would have a total cost of 5 times 10 cents. It would cost me 50 cents. So this is measuring in dollars. The second call, 10 minutes, 10 cents each would be $1. And then for 20 minutes it would be $2. So in total, this plus this plus this would be $3.50 that I paid to make these long distance calls. Okay, so what do we do first? Well, we took 10 cents times 5 plus 10 cents times 10 plus 10 cents times 20 and added those together and we got $3.50. Now alternatively, somebody else might say, well, I'm going to add up the minutes first. So 5 plus 10 plus 20, that's going to be 30 plus 5 is 35. And I'm going to take that 35 and I'm going to multiply that whole thing by 10. So 0.10 times 35 minutes would actually still be $3.50. So if you look at this visually, we've actually, from this step, the difference between these perspectives is that this 10 is kind of distributed to each of these numbers. It has been multiplied into each of these numbers first and then added together. So the distributive property kind of looks like this. If you have A times B plus C, then that's going to give you the same thing. So remember, that can also mean equals or same as A times B plus A times C. So even though we don't show the multiplication sign here, it means multiplication. So for example, we had 3 times x squared plus 2x plus 7. Well, that's basically saying triple every one of these things. So I'm going to triple the x squared, i.e. distribute. I'm going to triple the 2x. Well, if I triple 2x, that means I have 6 x's. If I triple the fact that I have 2 copies, I have 6 copies. 3 times 7 is 21, and so I would be left with this. I have just applied the distributive property, and I've distributed. Okay, well, let's combine these ideas. So let's just say I'm doing this. 3 times x plus 2 minus 4 times x plus 3. Okay, well, if I want to simplify this, if I want to basically distribute combine-like terms, categorize this function that I'm going to get here, which appears to be linear, first thing I'm going to do is I'm going to get rid of my parentheses. So I'm going to distribute. I'm going to take care of that. Multiplication, what's inside the parentheses comes first, but there's nothing I can really do there since I don't know what x is, and I can't add that to 2 if I don't know what it is. So I will get 3x, tripling 2, so I get 6. Now here's where a lot of people have a challenge. They're like, well, do I distribute the 4 or do I distribute the negative 4? Well, ultimately, you can kind of go both ways, but I like to think about it this way. Subtracting 4 is the same thing as adding negative 4. So for me, it's a little bit easier to take its sign with it and say, well, this is negative 4 times x plus 3. So negative 4 copies of x would give me negative 4 copies of x. Negative 4 copies of 3 would give me negative 12. That's what it would multiply out to. Well, now I can combine my like terms. So I have 3 copies of x. I have I remove 4 copies of x. That means I'm in debt 1 copy of x. So that and that are combined. I have 6 minus 12. Well, if I have $6 and I take away 12, I'm in debt $6. And usually we don't write the 1 there. You can write it there, but usually we just stop here and say that's negative x minus 6. Okay, one other place where people get tripped up. Now, this is actually stuff that we will be doing and will be using. So say you have 3x plus 6 minus 3x plus 4. All right, well, so what a lot of people want to do